Before you scan anything, get written permission from the actual network owner. Record the source, exact target range, allowed methods, time window, escalation contact, and stop condition. A private-looking address is not permission. Here, we own a disposable Docker lab. The only approved range is 172.30.42.0/29, and any command pointing elsewhere stops the exercise. An open port is an observation, not proof of vulnerability or compromise. Here is the whole lab. Kali is point 2. The intended web service is point 3 on port 80. The intended admin service is point 4 on port 8000. Host point 5 should have no listener, although the lab owner deliberately started one on 8080 so we can find and remove it. The Docker bridge is point 1. A /29 covers 8 addresses, and compose marks this network internal, true, so it has no external connectivity. Do not trust a diagram when the machine can tell you where it is. First, confirm Nmap 7.99. Then check eth0, the validated output shows 172.30.42.2/29. Finally, ask the kernel for the route to the lab range. It stays on eth0 with source point 2. These two lines are our go or stop gate. If the interface, prefix, or route differs from the written scope, stop and fix the lab before scanning. Now run Nmap SN and 172.30.42.0/29. SN performs discovery without the later port scan phase, and N skips reverse DNS. Nmap considered all 8 addresses and reported 5 hosts up, the bridge, the scanner, and our 3 synthetic hosts. On this local Ethernet-like network, Nmap normally uses ARP discovery. A missing response would not prove that no host exists. Filtering and network position can hide one. Discovery tells us which addresses responded, not what should be running. Our inventory command uses TCP connect mode against only 3 owned hosts and 4 justified ports, 80, 443, 8000, and 8080. SC asks the operating system to complete ordinary connections. That is transparent and likely to leave logs, which is useful in this defensive lab. Reason shows why Nmap assigned each state. The results are clean enough to reconcile. 0.3:80 is open with SYNAC, 0.4:8000 is open with SYNAC, and 0.5:8080 is also open. The other tested ports returned closed with con refused. The first 2 match the owner's inventory. Port 8080 does not. Call it an unnecessary exposure, not a hack and not a vulnerability. At this point, labels such as HTTP proxy mostly come from the port number. To ask what is actually answering, add SV, but keep the target and port list narrow. Version light uses intensity too, so Nmap sends fewer probes and finishes faster, with a lower chance of exact identification. In the validated lab, all 3 open listeners answered as Python Simple HTTP Server 0.6, version 3.13.14. Treat that string as a fingerprint to check against configuration. Version detection sends application probes and can stress defective services, so coordinate the window and omit it on fragile systems. The scan is not the conclusion. The diff is. Our table says 0.5 should expose nothing, so the lab owner stops only that synthetic 8080 listener. Then we retest one known host and one port with Nmap STPN and P8080 reason 172.30.42.5. PN stays limited to this known target. It forces the port check without broadening discovery. The result changes to closed, reason con refused. The host was reachable, but no application accepted the connection here. That does not prove a firewall policy or service safety. Preserve the scope, command, timestamp, intended state, and result. Then review ownership, binding, firewall rules, patching, and whether the listener is needed. Remember the loop: authorize, confirm scope, discover, inventory narrowly, compare with intent, harden, and retest. Copy the checklist from the description, subscribe, and see the WSQ cybersecurity courses below.